All right, here we go. The last topic in this section, and it's adding and subtracting rational expressions, i.e. fractions, with the same denominator and the least common denominator. Well, most of you remember, if you have the same denominator, if I had 5 over 9 plus 2 over 9, you just add the numerators and keep the denominator, right? Yay. Same thing for subtraction. So if the denominator is the same, right? If the denominator is the same, then everything's great, right? If you have the same denominator, and I don't know why this says P over Q and R over S. That should probably say P over R and Q over R. Are rational expressions, then you add or subtract them by simply adding or subtracting the numerators or adding or subtracting the denominators. So if you're adding two fractions with the same denominator, add the numerators, keep the denominator. If you're subtracting two fractions with the same denominator, subtract the numerators and keep the denominator. So that's going to be really nice because here I'm just going to add my numerators. I've got 4p minus 3 plus 3p plus 8 all over 2p plus 7. Now, if you notice, I grouped these using parentheses. I really didn't need to because we were just adding, so let's take them away now. If I were subtracting, they would be very important. So I want you to understand that they're here. It's just because I'm adding, I don't really need them. Because now all I need to do is to combine like terms. And so I've got 4p plus 3p and then minus 3 plus 8. So it's not necessary to group them together. You could probably go straight to the final answer. But if I do group them together, 4 potatoes plus 3 potatoes is 7 potatoes. Negative 3 plus 8. Again, you don't make that 11, right? You're negative 3. You read it from left to right. Negative 3, so I'm down $3, and you give me $8. You're so nice to me, which means I now have $5. And then over my denominator, and I kind of jumped the gun by writing it in red because I should ask myself, can I factor anything and reduce? And I can't because look at those weird numbers. So that is example 1. Example 2. So here I'm subtracting and the denominators are identical. Yay. So I'm going to do the numerators subtracted. I don't need parentheses because these are just single terms. And then all over y minus 2. Well, it looks like I'm done. Wait a minute. 8y minus 16. Oh, those both have a greatest common factor of 8. Check it. 8 times y, 8 times 2. Woo. And so now, look what I can do. I have common factors, or a common factor, this and this. So I'm just left with 8. That's actually pretty handy. Similar thing going on here. I've got 3y minus 6 over y squared plus 3y minus 10. And so just like before, I recognize, oh, I can factor out a 3. And then the bottom is a diamond problem, right? Where I'm saying what two numbers multiply to negative 10 and add up to 3. Well, the two numbers that multiply to negative 10 and add up to 3 would be 5 and negative 2. So that would be x plus 5. Oh, where's x coming from? Oh my gosh, I have to watch myself about that. Y plus 5, y minus 2. And so now the y minus 2's will divide out, leaving me with 3 divided by y plus 5. All right. I want to check the homework because I'm afraid they're going to have something on there. Homework number 12. So, oh, these are not bad. All right. It's one like number 5 and number 7 that I want you to be careful with. Do you see how we're subtracting all of this? So that means you're not just subtracting the 10x, you're subtracting the 19. So whenever you see, go away. Help me. Okay. Whenever I see something like this, this is where I definitely want to use the parentheses because I'm subtracting. So I'm just going to give you like a quick example of that. Also, I want to see if they give any other. No. All right, good. They don't give you anything to trick you, which is nice. But if I had something like 4x plus 2 over x squared minus 7, and then minus 3x minus 4 over x squared minus 7. Here, I don't just say 4x plus 2 minus 3x minus 4, because this subtraction symbol applies to everything here. So this is where I say that you should really kind of think about doing this. And then you would say, okay, that's 4x plus 2 minus 3x plus 4, right? Because you're going to distribute that negative sign. And of course, that's all over x squared minus 7. And now I can combine like terms. 4x minus 3x is x. 2 plus 4 is 6. And then all over x squared minus 7. So just be very, very, very careful if you have a situation like this. All right, the next one, or the next topic is least common denominators. And to add or subtract rational expressions with different denominators, you have to get a least common denominator. And so if you're looking for least common denominators, this is what you're going to do. Step 1, factor each denominator completely. Meaning that I'm going to look at 6y, and again, just denominator, right? I don't care what these are. Those could be anything. Who cares? Blah, blah, blah. LCD, denominator. So if I look at 6y, that is 2 times 3 times y. And then 4y plus 12 is 4 times y plus 3. But that's really 2 times 2 times y plus 3. Okay, I factored them. I broke them down. Completely broke them down. Then step 2 has this long sentence. It says the least common denominator is the product of all unique factors found in step 1. Each raised to a power equal to the greatest number of times that the factor appears in any one factored denominator. So basically, and by the way, guys, these are the two we're comparing right now. Right, that's the 6y. So if I look at these two denominators, I don't need this number 2 3 times. All I need, the most number of 2's I see, is 2 2's. So because they share this factor, when I figure out my LCD, that factor I'm only going to write down once. But then everything else I have to write down. So 2, and then I've got a 3 up there, and then I've got a y, and then I've got a y plus 3. But I only needed the 2. Those are common, so they can share a 2. They don't need to both have their own 2's. That's one way to look at it. Another way to look at it, I didn't mean to do that, is this. It's the product of all unique factors. Well, that's a unique factor, right? Nothing else has a y plus 3. Nothing else has a y. So those are my unique factors. The ones that aren't unique, and that's actually kind of unique, right? So I take the product of all my unique factors. I've lost my colors here. But then each is raised to a power equal to the greatest number of times that factor appears in any one. So the reason why I'm taking 2 of these is because that's the greatest number of times it appears. So that's really 2 squared, right? And so now my job is just to multiply all this together. So 2 times 2 is 4 times 3 is 12, and then y plus 3. And so that would be my LCD. Kind of crazy, but sometimes they're kind of awkward. Sometimes, like the next one is actually easier. So if I look at the next one, if I look at my 2 denominators, x squared plus 4x plus 3. Well, that is simply what 2 numbers multiply to 3 and add up to 4. 1 times 3, 1 plus 3. The second denominator, x squared plus 10x plus 21. What 2 numbers multiply to 21 and add up to 10? 7 and 3. So that'd be x plus 7, x plus 3. So my least common denominator is the product of each factor. So here's a factor, here's a factor, here's a factor, here's a factor. But only the most number of times I see it in any one line. So x plus 1 is a factor. The most I see it in any one of those is 1 time. X plus 7 is a factor. The most I see it is once. X plus 3 is a factor, but I only see it once in this factorization and once in this factorization, so I'm only going to write it down once because that's the most I see it in any one of those factorizations. And I'm done. What? Okay, so again, let's do another one because these can be kind of weird. So 5x squared minus 5x. Well, this one's kind of tricky, but remember, I can divide out a 5 because they both can be divided by 5. But x is the smallest power, so when I'm doing that, I can pull that smallest power out. And so this would leave me with 5x times x minus 1. Right? Because that would be boop, 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 and that would be 1. That's as far as I can go. Then I've got x squared minus 2x plus 1. Well, that's a diamond. What multiplies to positive 1 but adds up to negative 2. Well, that's kind of tricky, but negative 1 times negative 1 is positive 1, and a negative 1 plus a negative 1 is negative 2. So now my LCD equals, well, 5 is a unique factor, and the greatest number of times I see it is once. X is a unique factor. The greatest number of times I see it is once. X minus 1 is a unique factor, and the greatest number of times I see it is twice. So you would write it as x minus 1 squared. Because again, remember that's x minus 1 squared. Okay. There you go. There's an example of where one factorization has more than one of that unique factor. Okay. Is this the last? Oh. What? Okay, look, one more. Example 7, again, it's that tricky one where you have x minus 3, which is just x minus 3, right? I mean, that's all you can do with x minus 3. But 3 minus x, remember, can be written as negative 1 times x minus 3. And so here, my LCD would be negative 1, which is the most I see it is once, and then x minus 3. If it helps, I can write x minus 3 equals. So that's kind of weird. All right, so when I look at the homework, that's what you're doing on 8 through 12. Number 11 is basically what I just did with x and y, okay? And the last example has writing equivalent rational expressions. And if I look in the homework, that's these last ones. And so basically what you do in a situation like this, what I do is I ask myself, what do I multiply this by to get 72y to the 9th? So if I have 9y to the 5th, what do I multiply 9 by to give me 72? Well, 9 times 8 is 72. What would I multiply y to the 5th by to get y to the 9th? Well, y to the 4th would give me y to the 9th if I multiplied it. So I look at the denominator I have and the one I want to go to, and I try to figure out what would be multiplied to get that. Essentially, another option that you can think of about what I did, I don't want to do that, is this. I divided. Right? 72 divided by 9 is 8, and then I subtract my exponents, and I get 8y to the 4th. And so that means I'm now going to take the numerator and multiply it by that same factor. So 3 times 8y to the 4th would be 25. Yeah, 3 times 8 is 25. 24y to the 4th. And that would be my equivalent expression. And so the ones in the homework, there's some a little bit harder one, like, yeah, I'll do one like 14. 15 is not bad at all. But 14 and 16 can be a little tricky. So if I had, let me look again at that. Oh, yeah. So if I had an example like this, 5m minus 2 over, let's say, 12m plus 4 equals 4b times, or not b, I don't know my alphabet, 4n times 3m plus 1. So I'm going to look at my denominators, and the best thing I can do on this one is to factor it. So really what I've got here is 5m minus 2 over 4 times 3m plus 1. All right, so now I'm factored. And lo and behold, I see my 4 and my 3m plus 1. So what's new over here? The 4n, right? Again, if you were to take your denominator you're going to and the one we just had, right, if you were to divide these, you would be left with n. And so that means that what I've multiplied by here was n. So now I've got to multiply the top by n. But I've got to multiply both of these by n. So 5m times n is 5mn minus 2 times n, which would be minus 2n. So that should help you with number 14. And then number 7, or is it 17? I think I messed up on my number. No, it's 16. Let's say I had 12 divided by x squared minus 8x minus 20 equals what over x plus 3, x minus 10, x plus 2. Well, all you have to do is factor this. If you were to factor this, it would be really quick and easy. You're going to be like, oh my gosh, right? Wouldn't that be positive 2 and negative 10? So if you look, this has this part, what's new? X plus 3. So all that happened here is this first denominator was multiplied by x plus 3. So that means I've got to multiply the top times x plus 3. And so that would give me 12 times x plus 12 times 3. So don't overthink those. All right. That's homework. How you do examples for homework 12.